Publish the blueprints for a self-driving car's brain, free for the whole world. That is the step Japan's Tier 4 has just taken. And the way I read it, it could change how the industry builds the brains of our cars. But I can't celebrate without reservations. Even with the blueprints out in the open, who actually mass produces the chip? That page is still blank. Today, let's read both the light and the shadow in this news. Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today, we're covering Tier 4, Japan's leader in self-driving software, and its plan to open source even its AI chip design under a national program. By the end, you'll see not just the announcement, but the full map of 3 parallel national projects, and the real challenge left on the road to mass production. Here's today's news in one picture. We'll lean on this diner story all the way through the opening section. Imagine a town with no proper diner in front of its station. Residents travel to the next town over just to eat. So the town decides to build a diner it can be proud of, right by the station. The town sets up 3 separate subsidies. Project 1 develops the signature menu. Project 2 builds a test kitchen to actually try the cooking. And Project 3, today's main character, publishes the finished recipes for free, so anyone can open a restaurant serving this taste. Each project runs on its own deadline. All 3 projects are moving along nicely, but read the master plan closely, and something important is missing. How do the 3 results come together into one restaurant? And who actually builds that restaurant and runs it? Running a restaurant takes more than a recipe. You need to serve the same taste every single day, keep things clean, hire staff, and commit to staying open 10 years down the road. Handing out free recipes doesn't guarantee anyone will open the doors. Meanwhile, in the next town, a big chain has already set its opening day 3 years out, and it's preparing steadily. And here's the tricky part. All 3 projects can be called a success, even if no restaurant ever opens. Finish an impressive report and a beautiful recipe book, and the project scores full marks. But what the townspeople really want isn't a report. It's a place by the station serving warm meals. From here, let me walk you through what this actually looks like in the real semiconductor industry. Our main player, Tier 4, is the Japanese company leading Autoware, the open-source software for autonomous driving. On August 14th, Tier 4 announced it is joining the next-generation Edge AI semiconductor program run by JST, Japan's National Science and Technology Agency. Under a research project led by Professor Kawahara at the University of Tokyo, it will develop a software-defined SoC for Level 4 autonomous driving. Tier 4's role is the logic design of an AI chip that makes end-to-end autonomous driving inference more efficient. What stands out is the plan to open source not just the design assets, but the compiler and the rest of the toolchain. The chip will, of course, work with Autoware. A company that built its track record on open software is now extending that philosophy into silicon. A quick look at the technology. Today's autonomous driving AI is moving toward handling everything from perception to path planning in one transformer model. But a car can't draw data center scale power. So this dedicated architecture reuses data inside the chip to cut traffic to external memory and adds circuits specialized for matrix operations and attention, raising power efficiency. The other clever piece is TOSA, a standard intermediate representation. AI models built in PyTorch and similar tools are converted into this common TOSA format before they reach the chip. So when the AI models evolve, you update the compiler and runtime instead of redesigning the whole chip. It's a smart buffer between fast-moving AI and slow-to-build silicon. Now for the heart of the matter. Public attention is on the headline, open sourcing a chip design. And I agree, it's a meaningful challenge. But what caught my eye wasn't the announcement itself. It was the bigger map of national projects around it. Tier 4 is actually involved in at least 3 publicly funded efforts running in parallel. First, Microautonomy, under NEDO's Green Innovation Fund, a software program targeting a 70% plus cut in power consumption by 2030 while keeping Level 4 capability. Second, ADSOC, a demonstration chip being developed under a separate NEDO program. And third, this new JST project for open logic design. Map it back to our story. Menu development is Microautonomy. The test kitchen is ADSOC, and the free recipes are this JST project. The deadlines all line up around 2030, but nowhere is it explained whether the JST design goes into ADSOC or some other chip, or when it merges with the software platform. The merging point of the three projects just isn't drawn. That's how it feels to me. Meanwhile, on the private mass production track, Denso is co-developing a next-generation automotive SoC with MediaTek, targeting market launch in 2029. That one is for ADAS and cockpit use, a different animal from this Level 4 design. But the partner and the timing are clearly on the table. For the JST design, which silicon does it finally land on? Who takes on automotive-grade production, functional safety, and 10-plus years of supply? That's still not visible. One more thing bothers me: the yardstick for success. Microautonomy, on the software side, carries adoption targets like 100,000 GitHub stars and 3,000 contributors. The JST side also values presenting results at international conferences. Reach design, papers, and public release, and the research counts as a success. But growing star counts and mass-producing autonomous driving chips in Japan are two different things. Research success and industrial policy success are not the same. Let's face the worst case. If Japan's autonomous driving keeps slipping, local governments and transit operators may end up buying everything: vehicles, AI, remote monitoring, maintenance, as one package from overseas companies. Using foreign technology isn't bad in itself, but if three publicly funded programs never connect to mass production and Japan imports the whole stack in the end, the loss goes beyond research money. Driving data, improvement know-how, and control over software updates would all flow overseas. That's my concern. So what should we watch? For me, it's whether a company steps up and says, we will mass produce this open design at automotive grade. The path to a prototype exists. The question is, what comes after? Who builds and runs the restaurant? There isn't much time left before 2030. I'll be watching for a real merging blueprint. Let's wrap up. Tier 4 joins the JST program, aiming to open source the logic design and toolchain for a Level 4 AI chip. On the other side of the ledger, Microautonomy for software, ADSOC for the test chip, and this open design make three national projects with no visible merging point and no confirmed mass producer yet. Publishing free recipes is not the same as opening the restaurant. Even so, connecting software all the way down to silicon in the open could be a real step forward for Japan's autonomous driving. That's how I see it. All the more reason not to stop at applause, but to watch who actually opens the shop. That's what this news left me thinking. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.